Hello and welcome to the 7th video in this series making simple Flappy Robin for the iPad and iPhone using Cocos2d. So this video then we're going to get the Robin in a state of jumping on the screen, and to do that we actually don't need to do very much. The main part is inside the update Robin here with the delta time, and what we have to think about is how we know with each update how far the Robin has moved and in which direction. So if we think about what we know how long it was since the last update, that's delta time. We have an acceleration that we apply on the Robin, which is our gravity value inside constants here. And from those two, we also have a speed that at the end of the last update, the Robin was moving. Or in other words, we have an initial speed, an acceleration, and a time. Now, if you go onto Wikipedia, you might remember from school, if you've finished school or if you're still in school, then you've probably done this recently, but everybody I think goes through to have a look at these equations of motion called the Suvat equations, and we'll be using two of these. One is this one, v equals u plus half a t, so the new velocity, so the new speed is the initial velocity plus the acceleration times the time. And then we can also work out the distance travelled in this since the last update by doing initial speed multiplied by the delta time plus a half times acceleration, our gravity, times time squared. Now if you're not particularly maths familiar, that might look a bit complicated, but it's not, it's very simple. But they allow us to make the motion of the Robin look relatively realistic. So inside the update then, we'll say that if self, or sef as I just typed, self dot and state is equal to k Robin state moving. Now we only want to do the update obviously if the Robin is in a moving state. If it's in a stop state, game stopped, then we don't. Then we'll work out the distance and then we can work out the new speed. I'll separate all this out so it's fairly clear. So we'll make a distance equals to 0 and we'll make a new speed equal to 0. And this new speed is then the speed that the Robin its new initial speed for the coming update. So first of all, the distance then is equal to the initial speed multiplied by the delta time, and it was plus a half multiplied by the acceleration, which is our gravity, multiplied by the time squared, or times multiplied by time, like so. And that gives us the distance that the Robin has travelled since the last update. Now as long as we keep everything positive going upwards and negative going downwards, this will resolve either positive or negative correctly and the jump will appear realistic. And now we've used our speed y, our initial speed, we can update our new speed. So with our speed y plus the gravity multiplied by the delta time. And now what we can do is set our speed y then equal now to this new speed, because we've used our initial velocity, which was our speed y, to work out the new speed at the end of this update, and now we can update then our initial velocity for the next update call. And now what we need to do is update the position of the Robin reflected by the distance. So we want to use our CCP, and then we use self.position.x and then self.position.y plus the distance is all we need to do. And that's now our Robin updated and its initial speed for the next round updated. The only thing we need to be careful of in this function is whether it's hit the top of the screen or not. So we'll say that if self.position.y is greater than the top of the screen, which we've set up, then we'll set the position to the top of the screen. So I'll just copy this line here, and here instead of this we just want to keep it at the top of the screen. But what we also want to do is it would still have a speed maybe positive going upwards here, which would make it stick to the top of the screen. We don't want to do this, so we'll set the initial velocity now to 0. So once it hits the top of the screen, it'll effectively then, what we'll see is it'll start falling down the screen. That's all we need to do then for the Robin. Now what we need to do is jump into our intro scene, and just underneath the initialize of the Robin here, I also want to now reset the Robin. So we set its state correctly. You remember that inside crobin.m we set its speed to its starting speed when we first press, and also its state correctly. And now going back into intro scene, then we now have to deal with the updating. So the first thing we'll do is go into this update section here. I'll delete this comment now. And what we need to say is we're going to first of all make a boolean and call this game over and set this equal to no, and you'll see why we've got this in this way in a minute. And we'll say that if our game has started, and I'm just checking I've set game started to no, indeed I have here. So if we're in a game running, so if game started is equal to yes, then here we want to do various stuff. And what we want to check at the moment, because we don't have any tubes, is simply whether Robin has fallen too low and has hit the floor. So we'll say that if a Robin.position.y is less than our floor y, then we'll say that the game over is now equal to yes. And later on, obviously, we'll then add some collision detection for the tubes here, where it would then also be set to yes. And now what we need to do is we want to reset the Robin to the middle of the screen. Now we might later on in the application change where and how we do this, because we'll add in eventually a label that says game over, which has a pause and then resets the Robin after a couple of seconds. But for now we'll just take the screen size line here and temporarily for the next few videos just drop that in here. Whoops, sorry, not in here, after the game over here. And then we can set the Robin's position, so we can set the Robin.position then equals CCP, and then we simply want to take exactly the line that we used for positioning the Robin, like so. Oops. So that then positions our Robin back to the middle of the screen when it's gone off the bottom of the floor, and last but not least we want then to reset our Robin. And I keep repeating, but for the last time, don't worry too much about the logic with game over and reset and where we do what, because we'll be adding to this when we put some sort of finishing touches to the game in with game over labels and high score labels appearing and pauses and stuff. We'll be adding in a start, a stop, a re-enable after game over and things like this later on. But this is just to get it into some sort of running state now. So here we've got, if the game is started, update our Robin in the case of the game over. And in fact, I'm actually going to do something else here that's popped into mind that can make it a little bit smoother for later. We'll say if the game over equals yes, then we found a game over, and now what we'll actually do is we'll drop those lines into here like so. And what we'll also do then is obviously we'll say that game started is now equal to no. And that means we won't do any of this position checking here or later on collision detection or anything like that. Of course, there's one valuable thing missing from this section here, and that is we need to actually update our Robin, otherwise nothing will happen. So we'll say Robin and update Robin with our delta time, so we can update our position if the game is actually running. And now we've got this update section running, we've got just one more tiny thing to do, and that's actually deal with the sort of game running logic. So I'll just make some space here inside the touch began. And what we now need to say is, if we've touched the screen and the Robin's state is equal to k Robin state stopped, that means the Robin's in a stop state. And we can also, well no, we actually just need the Robin state stop for the moment here. Then what we want to do is we actually want to set our Robin state now equal to k Robin state moving, which will cause the Robin to be updated. And also we want to set game started now equal to yes. And even if the Robin was already in a moving state here, so we don't do this, we want to say that if then the game is started is equal to yes, so the game is running, then we've touched the Robin, so we want to set the Robin start speed to make him jump up again. So we simply take our Robin and go set and start speed like so, which will make the Robin jump again. So I'll just build that and make sure I haven't made any silly errors. And what I'm going to do is run the application and hope that everything's okay there. There were some pauses whilst I was typing things, so I was just double checking my logic. So I'll just run the application. And now you can see when I tap the screen, the robin sticks to the top of the screen, and it's a little bit jerky because it's running whilst recording, but you get the idea. And if I let the robin now fall off the bottom of the screen, he gets reset to the middle, and we can start again. And he gets reset to the middle. So good. So what I'll do is very quickly is actually just run this on the iPad, something I haven't tested before the video, so I hope that the gravity and everything is looking okay. I'll just click run. So we have the application up on the iPad here, and you can see again that the robin jumps and sticks to the top of the screen and falls off the bottom of the screen and gets reset. Okay then, so that's a pretty big step made in this video. We've now got probably the trickiest part of the entire application, making the robin rise and fall fairly realistically, detecting the touches on the screen. And next video we can start adding so the clouds, the trees and the mountains and stuff that all scroll by to give the impression that the robin is actually flying. So thanks very much for watching, and comments, questions, criticisms welcome as always on YouTube.